I am writing a message. Please be informed. One day scheduled on Thursday, 22nd January. Okay. And venue will be the Van Al Ghazali. Okay, and students required to bring their own answer sheets. Okay. So this is the announcement. Thursday, 22nd January 2026 from 8 p.m. to 10 p.m. Okay. Also, I should announce for Group C and Group D. Okay. So you have to bring your own answer sheets. Okay. The blank papers. 5, 6 paper you must have. Okay. This is the final. Okay. So it's finalized that your test will be on 22nd January 2026. Time will be 8 to 10. Malam. Venue Diwan Al Ghazali. I will also discuss the paper format, but before 1 week, not now. And secondly, I will give one lab assignment by this week, and the lab group assignment. One is individual assignment, and one will be lab group assignment. Lab group assignment will be the alternate of your lab project. Okay, uh, I will give the same assignment as previously Dr. Feroz already given to her students. Okay, so no issue. These are the two items I will give you by this week in your respective lab physically. Can I give one week time or 10 days time you can submit? Um, we'll see some more algorithms. Some more algorithms. So you have to take your pencil or paper. So just follow, like last time we have seen, I think, Prim's or Kruskal algorithm. Yeah, it was Prim's algorithm. Today we will see Kruskal algorithm. Okay. Let me share the so I'm sharing YouTube video link for the Kruskal algorithm. Very, very simple. Okay, let me share this. We have actually limited number of algorithms and selected number of algorithms, not all algorithms. Okay. Uh, After this, we will see disaster algorithm. Okay. Okay, same thing, but in different way. We have to solve the same problem, which is minimum spanning tree. You know why we use minimum spanning tree? What does it means? So same thing we will solve that we have to finalize the shortest path, shortest route. Okay, so let's start. So again, this is our graph, and in this graph, we have to find or we have to remove two things. Number one is the loop, and number two is the redundant link, duplicate link. Again, same thing. Whenever you see the graph, I give you a graph. So what do you have to do? You have to remove these two things. Number one, in first step. Okay, you know what is vertex, what is the edge, and what are the weights. So these are the weights and vertex and edges. So number one, we have to remove all the loops. Any edge that start and ends at the same time is called loops. So we already removed both the loops. And now we have to remove the parallel edges. So how many parallel edges we have? We have these two parallel edges. And the rule is that we have to keep the edge having less weight. Okay. So in this graph, vertex A and C are connected by two parallel edges having weight 2 and 12 respectively. So we will remove 12 and keep 2. Simple, very simple. Okay. And then now the variation. Now we see the change. This is our graph, and we are now ready to find MST, minimum spanning tree. So kindly draw this graph on your paper. We will be using in our calculation. So here, see, here you have to create the edge table. Okay, we have to create the edge table. So an edge table will have name of all edges along with their weight in ascending order. So okay, we have how many weights? How many edge? 1, 2, 3, 4, 5, and 5 weights. We will write in ascending order. Okay, like 1, 2, 3, 4, 5. So create the edge table first. Now, if you look at the graph, then you can notice that we have how many edges? We have 5 edges. 1, 2, 3, 4, 5. 5 line, 5 edges or 5 connectors. How many connection line? 5 connection line. Okay, so we call edges. So we have 5 edges, and we have their respective number of weights also. So our edge table will have 5 column. Our table will have 5 column because we have 5 edges. So we have to write the edge and weight in ascending order. So now look at the graph and fill the first column with the edge of minimum weight. You know, minimum weight is 1. And which is the edge is BC. And the edge is BC. Yes. So in this case, edge BC is of least weight. So we select it. So we will write edge and weight in the table. We have to fill BC and 1. BC and 1. Very simple. So we have to create the edge table first. And now look at the graph again to find the edge of next minimum weight. So in this case, we have, see, we have 2 weights having same number. Like edge AB and edge AC having the minimum weight. So we will select both of them separately. BC and BA and the same weight 2, 2. So in this case, we have 2 or more edges with same weight, so we can write in them any order. So it's up to us. We can write first AAC or first BC. So in any order. So we will make this table as per the weight number in ascending order. So now look at the graph again. Next is 3 DC. Very simple. And last but not least, we have BD. And the edge number is 5. Okay. This is time to find the minimum spanning tree. We already cleared the edge table. So now see, our graph has how many vertices? 4. A, B, C, D. These are the vertices. A, B, C, D are the vertices. So our MST will have 4 minus 1. It means 3 edges. Always remember this. The MST must have total number of vertices minus 1. Here in this case, we have 4 vertices. So our MST will have 3 edges. So to find the minimum spanning tree, we will start from smallest weight edge. Smallest weight edge. and keep selecting edges that does not form any circuit. You know circuit, the loop circuit means the cycle with the previous edge, with the previous selected edge. This is very important. So see here. So 1 is the smallest weight. So we'll select edge BC first, B and C. So we will highlight B and C. We'll draw BC. Okay. So 1 is the smallest weight. So we'll select BC, number 1. 2 is the next smallest weight and edge AB does not form any circuit. Okay. A and B like this here does not perform any circuit. So we already, again, let me see. So 2 is the smallest weight and edge AB does not form any circuit with the previous selected edge. So we will select AB. Yeah, like this. Okay. And then AC, definitely it will create a problem. 2 is the smallest weight. Okay, next. So if you select edge AC, it will form a circuit. It will form a circuit. Or we can say cycle. Okay, so we don't want this. We have to avoid circuit. We have to avoid making circuit. So we're going to reject edge AC. First two DC. Yes. So third one, we will take only 3. So 3 is the next smallest weight and edge DC does not form any circuit. If we select DC, so it will not form any circuit. So we'll select it. Yes, simple. So we got 3 edges. So we stop here because why 3 edges? Edges must be vertices minus 1. We have 4 vertices, so we'll go up to 3 edge. This is very important for Prim's algorithm and for Pushkal algorithm, both algorithms. This is our graph has 4 vertices, so our MST will have 3 edges. So this is our required medium spanning tree. Very simple. Okay, so this is basically another way to find the medium spanning tree with the help of Kruskal's algorithm. So what is the difference between Prim's and Kruskal algorithm? Yes, please. Now tell me the difference between Prim's and Kruskal algorithm. Hurry up. Yes. The purpose is same, no doubt. The purpose is totally same. About the working. Yes. What the difference? Clear and easy difference. Yes. The approach is in Prim's algorithm, the approach is vertex base. And the Kruskal algorithm, the approach is edge base. Vertex base, and this one is the edge base. Very simple. Understand? This is the actual thing. Both are for minimum spanning tree, no doubt. The output is same, M for MST, minimum spanning tree, but the approach is different. The steps are different. Simply, if I say the step or approach is different. So this is the okay. Understand? Yes. Any question? Any question? So very simple graph and simple explanation for Prim's algorithm and Kurzweil algorithm. I already shared a YouTube video. You can watch again and again and see. I will give you some practice question also. Okay. I will give some practice question, but not now, maybe next week. Just you have to do by your own. Like it will give you some practice. Okay. Okay. So now I'm moving towards the third algorithm. Don't worry, I will give you some like theory for this. Like what do you mean by Kruskal algorithm? Why we use it? What are the advantages? In what scenario we use Kruskal algorithm? At what scenario we use Prim's algorithm? Like this, I will give some theory also. Don't worry. I think no need. There will be no explanation, but I will give. Okay, so these are the two algorithms, Kruskals and Prim's. So we have to move towards disaster algorithm. Okay. Okay, now I'm sharing disaster algorithm. We have two levels of disaster algorithm. This is also very easy explanation. Okay, let me share. Okay, this is B, this is A. Okay, I just shared. They are saying. Okay, okay, let me share about the disaster algorithm. Okay, we have two levels of disaster algorithm. Okay, so what does it mean? Why we use disaster algorithm? Why we need this? The basic is that we have to find the shortest path again. Shortest path from one starting node to all other nodes in the graph. Okay, so we have to find the shortest path from one starting node to all other nodes. Okay, because we have multiple links, we have multiple routes. So along with these multiple routes, we have to find the one and shortest path. This is the purpose for the Dijkstra algorithm. Number one. So it works only when all edges and weights are positive. Okay, that's the value. And the algorithm basically chooses the nearest unvisited node. Nearest and unvisited node. Once a node is visited, its shortest distance will be finalized. For example, if what is the example for this? Finding the shortest road from your house to all other places in the city. Simply, we have to find the shortest road from your house to all other places. Your house to UITM, your house to McDonald, your house to any other place. Understand? So this is basically uh, the purpose for level 1 algorithm. We'll see both how it works now. Okay, disaster algorithm. It's just okay. In this video, we will learn to find the shortest path from vertex A to vertex D using disaster algorithm. Okay, how? What are the steps involved? Okay, let's start. So this is our graph. We have a same graph A, B, C, D. We have 4 vertices and we have some edges, the weights. We have loops and duplicate link or redundant link or multiple links. So same thing we have to apply here. The same two things. Okay, so here you can see this is our initial vertex. A, B, C, D, and this is our final vertex D, because we have to find the root along A to D. A to D, because A is our initial and D is our final vertex or destination. And we know the edge, we know the weight, we know the loops. So we have to remove the loop first. Okay, we remove the loops and we have to remove the parallel edges again. And we'll keep the 10. We will keep the 10 value. We remove the 12. Okay. And now we are ready to find the shortest path from A to D. So kindly draw this graph on your separate paper. We will use it. Now we have some calculation. Okay. So create a shortest path table. This is step number 3. So as our graph, we have how many vertices? 4 vertices. So we have 4 vertices. Our table will have 4 columns. So the step number 3 is create shortest path table. And shortest path table based on vertices. Vertices. So we have 4 vertices. So it will be 4 column. Number 1. So A, B, C, D. So we just write the same as the column name. So A, B, C, D. Okay. So we have 4 vertices. We have 4 column. So now in first row, write 0 in column A and infinity in other column. So we have to write this. How? We'll see next. But this is important. We have to write 0 and infinity. 0 and infinity. The rule will be now. Okay. This denote infinity. Okay. This sign is infinity. So what we have to do? Because first row, we have to write 0 in column A and infinity in other column. Simple. Why we write this? Because this is our initial. This is our initial root or initial vertex. That's why we write 0 in A and infinity in other columns. This is very important. First two. Okay, why we write? Because this is our source. We have written 0 in column A because vertex A is our origin. Vertex A is our initialization or initial root, or we can say source, same thing. So value in the column denotes the weight of the shortest path. So column 0, column A, we have 0. So it denotes that we are at vertex A. And infinity in all other denotes unexplored vertices. Infinity basically denotes unexplored vertices. So we are at A. We are at 0 because 0 is our source. 0 is our initialization or initial path or the start. Okay. Next. So now our first row is completely filled. Our next job is to find the smallest unmarked value in the first row. Smallest unmarked value in the first row. So how we find this? So looking at the table, we can say that 0 is the smallest unmarked value in first row, simply because others are infinite. Others are infinite, unlimited numbers. And 0 is the smallest unmarked value. So first row will be marked in square box. So we have to search and we have to find the smallest unmarked value in each row. So let in first row we have 0 and infinite. Infinite means many numbers, unlimited numbers. So 0 is the smallest simply. So we'll write the square box simply marked A. Now draw another row and copy all the marked value, only marked value in new row. So in this case, 0 is copied. Okay. So B, we just add another column and just write 0 because 0 is the unmarked value. We copy as it is. So as a column A was marked in the previous step, so we will now look for the edge that are directly connected with vertex A. So directly connected with the vertex A, we how many edges? We have two edges, C and B. C and B. Okay, but we have to write one. How? So find the edge that directly connects vertex A and B. So we know how many edges are connected with A and B. So in this case, we have the edge 5, edge of 5 feet that directly connects A to B. Sorry, A to B, we have only one. Yes. So now before we proceed further, I want to tell something about the minimum value formula. Yes, now we have to see the formula for the minimum value. Before proceed first, we will see the formula. Very easy formula. So minimum value formula is MVF. We call MVF. If we consider two vertex, X is a source and Y is the destination vertex. So an edge that directly connects them, okay, like A to B, B to C, so A is source, B is. So then we have the formula minimum of destination value comma mark value plus edge value. So we will take the minimum of all these. Destination value and mark value plus edge value, we get some number, some value, and destination value, we will take minimum. How? Machamana? See now. So the destination value in vertex, that is our column, and mark value is a source value or source vertex, which is X column. Edge vertex or edge weight, the edge weight is the edge that connects source X and Y. Y is the destination. So we have three things here. Destination value, the value in the destination, we have Y. And mark value, the source value basically we mark first, so which is X, for example. And the edge, we have to write its weight. The weight of the edge that uh, connects source and destination, X and Y. The A and B and C. Okay, so see here. Again, we have an example. How? So we have to solve this. So for example, we get the minimum value that put the destination vertex Y. Okay. For example, if destination value is 10 and mark value is 5 and edge value is 4. This is example. Okay, don't mix up. We will go back and see the value one by one. But now, Karan, for example, destination value is 10, mark value is 5, edge is over 4. So how we get the minimum value? Very simple. Minimum of destination value 10, 5 plus 4. Mark value 5 and 4. So minimum of 10, 9 is 9. See, very simple. Minimum function. This is basically minimum function. Minimum function will give you the minimum value, the smallest value between two, the small value between two number. So don't mix up what about destination value. We'll see in the graph. This is the example. For example, our destination value is 10 and the marked value is 5. Edge is 4. So as per the formula, minimum of 10 comma 5 plus 4, 9. So minimum will be 9. Understand this? This is very important. We have to apply all columns. Faham? Because next we will see the graph, so it will be easy. Okay. Let me move. So look at our graph, so we can fill the table like here. So as we are considering an edge between A and B, so source vertex A and destination vertex is B. Okay. Source vertex is A. And let me go back a bit more. Okay, now see again. So next step, to draw another row and copy all the marked value in a new row. In this case, we have 0, which is already marked. So we'll copy 0 only. As column A was marked in the previous step, so we'll now look for the edges that are directly connected to vertex A. Okay. So first, we'll see, find the edge that directly connected to vertex A and B. Okay. So in this case, we have an edge of weight 5 that directly connects A and B. Oh yes, okay, no issue. And then we have this formula, minimum value formula. Okay, so now see the graph. Okay. Now see, as we are considering an edge between A and B, so what is our source? Source will be A and destination will be B. And the weight we have 5, very simple. So we can get the minimum formula, minimum value with the formula. Okay. So in this case, we have the weight 5 that directly connects A and B. So find the edge that directly connects vertex A and B. Okay. Now see, this is our marked value. This is our destination value. This is marked value. This is destination value. So we write minimum of marked, destination value, because the formula is DEST value, which means destination value. And then we have a mark value plus edge. Edge is 5. Edge is 5. Edge is 5. Okay. And why is 0? Because 0 is the mark value. And B is the infinite. Infinite. We write the same thing here. Faham. So the answer will be 5. Answer will be 5. Why 5? Because infinite is mean many numbers. 100,000, 10,000, 1 lakh, billion, trillion. So the minimum of this comma 5 will be 5. So we get the 5. So we will put the 5 in column B. We will put 5 in column B. Like this. Understand? Very simple. minimum of infinity 0 plus 5. Why infinity? Infinity is our destination value, 0 is a mark value, and 5 is the edge between A and B. So now find the edge that directly connect vertex A and C. First AB and then AC. Very simple. So in this case, the weight is 10. That directly connects A to C. Okay. So if we consider an edge between AC, so source is A, destination is C, and the weight is 10. So we have a formula. So C is C. Now A and C. C is infinity. A is mark 0. Okay, 0. We can say 0. And the edge is 10. So again, the answer will be 10. Let me. Okay. So answer will be 10. Understand? Very easy. So we'll get 10. Minimum of infinity 0 plus 10. So infinity is our destination, 0 is our source, and 10 is our edge, A to C. The edge, the weight of A to C is 10. Okay. So we'll add same thing. So we find the edge that directly connects A and D. So is there any edge that directly connect A to D? No. A to B, A to C, yes, we have. But we don't have edge that directly connects A to D. So look at our graph. We find no such edge that directly connects vertex A and B and D. Sorry. So we will simply copy the previous value in column B, which is infinity. Yes. Okay. So now the second row is completely filled. Our next job is fill the smallest unmarked value for column 2. Okay. So smallest unmarked value for column 2 is 5, 10, and infinity. Yes. Which one is the smallest unmarked value? Yes. Yes. Smallest unmarked value. Anybody? Yes.
5.
5. Very simple. Good. So 5 is the smallest unmarked value. So I already shared this video. You have to watch this video 3-4 times. Okay. So now looking at the table, we can say that 5 is the smallest unmarked value in the second row. So we'll mark in the square box. Very simple. Okay. Now we start from B. Now draw another row and copy all the marked value. See, again, when you draw another row, you have to copy the marked value. Last time we have only one. Sekarang we have 2, 0 and 5. So we have write 0 and 5 and mark values, and we will go for C and D. So as column B was marked in the previous step, so we will now look for the edge that directly connect with vertex B. So vertex B, we have edges BD, BC. So we don't have to consider vertex A, which is already marked, because A is already marked. AB or BA is same thing. AB and BA is same thing. So currently we have only 2 edge. Which one? BD and BC. Okay. So find the edge that directly connect vertex B and C. So in this case, we have the edge of 4, that directly connects B to C. So we are taking the smallest basically. Okay, no issue. BC. So we consider the B and C. So B is our source and C is our destination. Okay, B is our source and C is our destination. So we know the value for C is now 10. We can see the previous row. Destination is 10 and B is 5 and the edge is 4. So very simple, 10 comma 5 plus 4 is 9. So the value will be 9. Very, very easy. It's a hectic thing. You have to calculate again like this. That's why I'm just supporting adding or taking the video so it will be easy for me and you people. Okay. So 9. Understand? So now we will see B and D. Very simple. Weight is 11, B to D. Okay. So B is our source, D is our destination, D is infinity, and B is 5 again. So infinity comma 5 plus 11. So 16 will be our minimum value. So now our third row is completely filled. So our next job is to find the smallest unmarked value in row 3. So which is the smallest value? Yes, 9. Okay. So 9 will be the smallest unmarked value. So, okay, looking at the table, we can say 9 is the smallest unmarked value in column 3. Sorry, row 3. So we'll mark in the square box. So draw another row and copy all the marked values 0, 5, and 9 in that row. Okay. So as column C was marked in the previous step, so we look for the edge that directly connect with C. Note, we don't have to consider A, B, they are already marked. So C to D. So find the edge that connects C to D. So in this case, we have an edge of 5. So C is our source, D is our destination, D is 16, source is 9, sorry, mark value is 9, and this is our edge is 5. So 16, comma 9 plus 5, 14. So 14 will be our answer. That's complete now, but we have one more step. So now the 4 row is completed. So our next job is to find the smallest unmarked value in 14. So unmarked is only one value. We have only one. So we will mark 14 because we have only one unmarked value. So as final vertex is D marked, so we stop here. So we now stop because our source is A and destination will be D. That's why we stop here. And now we have one last step. So column D has marked 14. This means our shortest path has weight 14, but it's time to find the shortest path using backtracking. Now we'll see the backtracking. With the help of backtracking, we will find the shortest path. So tick mark D as the destination vertex. We will go from backtracking. Okay, we just came with the table A to B and C and D, and then what we will do now? We will do the backtracking. Yes. Okay. There's a rule for backtracking. So backtracking is very simple. We will now move upward row by row. We will move upward row by row and will stop only when we find a change value. We find a change value, we stop. This is one thing. But we go row by row. If any change, we stop. Then we go next row. So we start from D. Start from the final mark value, which is 14. Follow the step carefully. So we are here. So we go one row up. We will move one row upward. So 14 now. Previously was 14. Now it's 16. So we move one upward. Has the value changed? Yes. Now 16. And we stop here and then. So take the vertex that was marked in that row. We have to take that vertex, which is vertex C. Okay. We start from D and we move towards C and we got the change value. Okay. And we mark, we tick C. Okay. Okay. Then see, after this, we got change value. So we move towards the same, like D to C. Now we move towards D to C. Understand how we don't go up because up is B. So we have to move towards C. We got change value. We stop here and then we move towards C. So move the pointer to the point at value 9 in column C. Okay. We'll move towards column C now, which is 9. So now we are at C. Now again we go up. We go up like we have done at D. We go up. If any change, we stop. Yeah, we go up. That definitely it will change 9 to 10. So take the vertex that was marked that row, which is vertex B. Now we move towards B and then we go up. One row up. Yes. So we have 5. So value change. Yes, because it's infinity. It's change. And then we tick A also. So the initial vertex is ticked. So we'll stop here. We'll stop here. Therefore, the required shortest path is C, A to B, and then C, and then D, like this. A, B, C, D. A, B, C, D. Not AC. Because from A we have two paths. A to B, we have two ways. A to B and A to C towards D. We can go via A, B, D, or we can go towards A, C, D, or we can go towards A, B, C, D. So the shortest path is A, B, C, and D, this one. So in this case, there are two or more columns with the same smallest unmarked value. Then you can choose any one of them. If you have two unmarked value, we can choose any one of them. Okay. This is sometime you can see this. In case there are two or more columns with the same smallest unmarked value. So you can choose any of them. No itana masala. This only denotes that there will be one or more shortest path in a graph. So again, our shortest path is A, B, C, and D. This is disaster algorithm level 1. Understand or not? I already shared the video. You can watch this video again and again. So we have 4 steps, very simple. Like you have to remove the loop, you have to remove the duplicate links, and then you have to create a table based on your columns. We have, or based on your vertices. We have 4 vertices, so we have 4 columns. You can give any name of the column like A, B, C, D. Okay, and then you have to fill that column first, all, and then you have to do backtracking. Backtracking. So these are the steps actually. Okay, remove all loops. Now you have to find the shortest path between A and D. So you have to create a shortest path table. How you do the table? With the help of column name A, B, C, D. So we have 4 columns. We have 4 vertices. It means you have 4 columns and then fill each and every row. Okay. The most important is when you start first. So first A is 0 and others will be infinity. Simple. This is understood. You have to follow this because you are at initial path or you are at source. See this again. Okay, see this again. Okay, I think disaster algorithm is a bit tricky, or you have to do some practice. So this is algorithm number 3. Then we have 2 or 3 more algorithms. Next week, inshallah, uh, we will complete. You have to practice disaster algorithm 2. Level 2 is also same. So, but I think it's enough. Should we proceed with disaster algorithm level 2, or it's enough? Yes. Should we proceed with level 2? Okay. So this is disaster algorithm level 2. So we have to learn the shortest path between A to F. Again, once again, you have to bring your pencil paper. Okay. So now we have how many? We have till F. F vertices A, B, C, D, E, F. So we have to find the shortest route between A and F. A and F. A is our source and F is our destination. Again, we will follow the same rules. We know the edge, we know the vertices, so we have to remove the loops. We have 3 loops here. And then we have a duplicate link, 2 loops and 1 duplicate link, parallel edge. We will keep 10 and remove 12. So now we're ready to find the shortest path from A to F. So how many columns we have? 6 columns. A, B, C, D, E, F. So column 1 will be 0, all will be infinity. Okay. Smallest unmarked value is 0. So draw another row and copy the marked value, which is only 0. So directly link from A to B is, we have 10 weight. Again, formula for the minimum value. Already know. Okay. Okay. Just revise. अस्सलामुअलैकुम जी, बच्चे पहुंच गए अल्हम्दुलिल्लाह। Okay. Okay, now B to D, the weight is 12 and we get 22. After B to E, to mark value and copy as it is. Okay. Okay, E to D. Okay, 4 is the weight for DF. 22 is the answer. This is our final vertex, so we stop here. So take the destination F. Again, we do the backtracking, same thing. So we move up, it will be no change. 22 is same. We move again. Okay. And we move one step up. Is there any change? No. Still 22. Again forward, upward. Yes, change. Then left. See, like this. So we did not take D. Yes, change. Again tick. Yes. A. So A, B, E, F. A, B, E, F. Now you understand. This is level 2 bit. A, B, E, F. This is our shortest path. So let me copy this video also. So I already shared this video. Okay, this is for A. Okay, that's all. So now we have only 2 algorithms. So next week we will complete the disaster algorithm. We will complete 2 more algorithms. Yes, any question?
No, at the moment, sir.
Okay, so very simple. We have 2 more algorithms left. So next week we will finish our algorithms, and then I will give you some revision. Week number 13 and week number 14 we have a test. Sorry, next it will be week number 13 and then we have a test. Okay, if you don't have any question, you may leave. Thank you very much. We'll see you tomorrow in your respective lab, tomorrow and day after tomorrow, and definitely labs will be face to face.
Okay, Doctor.
Okay, Assalamualaikum warahmatullahi wabarakatuh.
Salam. Thank you, sir.
Thank you, Doctor.
Thank you, sir.